Hello Pre-Calc students, this is day 2 of our polynomial unit, and we're going to start with the rational roots theorem or the rational zeros theorem. So if you have a polynomial with integer coefficients, if it has any rational zeros, then they're going to be in the form p over q, that's a ratio, where p is a factor of the constant term, so here's a constant term, and q is a factor of the leading coefficient. So to list all of the possible rational zeros, we want to start by listing those factors. So on top is p, on the bottom is q, and p is the factors of -2. So it could be 1 or it could be 2, and they could be positive or negative, because you could have a 1 times a -2 or a -1 times a +2. Factors of q, those would be the factors of 3, are 1 and 3. But again, it's still plus or minus, because it could be a -3 times a -1 that makes the 3. So now we need to combine these in every possible way. So every fraction will have a plus or minus on it. I'm going to have 1 over 3 and 1 over 1. And then I'll have 2 over 3 and 2 over 1. So these are all the possible rational zeros of my polynomial function. And then there are 8 possibilities. So to find the rational zeros, you just need to test them. And most people like to test the ones that are not fractions first to see if they're zeros. So for example, if I wanted to try 2, let's see if 2 is a 0. I'll put 2 in the box, and I'll line up my coefficients, 3, 7, -1, -7, -2. Bring down the first term and multiply and add. Multiply and add. Now I'm starting to get nervous that this is not going to work out, and so if you are sure, you can stop. You can abandon ship anytime you want. Once you realize that 2 is not a 0, so that one is no good. But you had to do the work to find it out. Alright, so let's try another integer. Let's try 1. I'm going to see if 1 is a 0, so I have 3, 7, -1, -7, -2. Bring down the first, multiply, add, multiply, add, multiply, add, multiply, and add. Okay, so this time I got a remainder of 0, so I know that 1 is a 0. I'm going to write that statement down. 1 is a 0. 1 is a 0. And when I divide by x minus 1, because x minus 1 is the factor, when I divide by x minus 1, I am left with 3x to the 3 plus 10 x to the 2 plus 9x plus 2. So this one here is called my depressed polynomial. It is the smaller polynomial I get after I divide. So I need to keep working on this. I need to find another 0, and I need to test again. Now I know that it's not positive 2, because I tested that and it didn't work. Positive 1 did work, but it's possible it would work again. So you could test 1 again, or you could test any of these others. I'm going to go ahead and test -1 next. So when I divide, the object is to try to get this depressed polynomial even smaller. So I'm not going to go back and divide the original problem. I'm going to divide the depressed polynomial. So I'm going to put -1 in the box, and I'm going to use these new coefficients, 3, 10, 9, 2. Now if this doesn't work, I'm going to just try something else. Bring down the 3 and multiply, add. Okay, so it did work. I chose well, so I didn't have to cross off too many things. But if you do have to cross off things, that's just part of the process, and eventually you will get there. You'll find one that's a 0. So -1 is a 0 also. -1 is a 0. which means x plus 1 is a factor. Okay, so now I have 3x squared plus 7x plus 2. And this is also a depressed polynomial because I divided again. And it's a quadratic, so I can factor this, or I could use the quadratic formula. I'm going to check and see if I'm trying to find the factors or the zeros. It says find all rational zeros and the factors, so I need both. So it doesn't really matter which one you want to do. You can do the quadratic formula or you can factor, but I'm going to go over factoring real quick. So to factor, if you have a number in front of your x squared, you're going to need numbers that multiply to the 3 times the 2. So they're going to multiply to 6. And those same numbers have to add to 7. So the numbers that multiply to 6 and add to 7 are 6 and 1. 6 times 1 is 6. 6 plus 1 is 7. You want to break your 7x into 2 pieces, 6x and 1x. I didn't change it. So that still makes 7x, but I broke it up so that I can factor. Then you bring down the terms that I didn't split up. I bring down the 3x squared, and I bring down the plus 2. Now you're going to take the greatest common factor out of just the first 2 terms. So the greatest common factor of the first 2 terms is 3x. And when I take that out of these 2 terms, I'm left with x plus 2. There really is not a common factor in these, but you need something, so we're going to factor out a 1, and I have x plus 2. So the factor x plus 2 is being multiplied by 3x and 1, so the 3x plus 1 makes its own factor. So here are 2 factors of the polynomial. The other factors come from my previous statements. X minus 1 is a factor and x plus 1 is a factor. So I have x minus 1 and x plus 1. And I can put f of x equals in front. F of x equals. So here's my factored statement. And then if I want to find the zeros, let's see, maybe I can do that over there. The zeros. That's going to give me -2. That's going to give me +1. That's going to give me -1. And this last one, if you're not sure what that's going to give you, set it equal to 0 and find it. So you would have 3x plus 1 equals 0. 3x equals -1 and divide by 3. X equals -1/3. So my zeros would be -1/3. Oops, I said half. And -2. +1 and -1. Okay, so factors and zeros. So now we have some practice problems. In 1 and 2, all you need to do is give me all the combinations of p over q, so I know what the possible rational roots are, but you don't have to test and find them. And then in problem 3, you're going to start with p over q, but then you're going to figure out which ones work. So this would be a good place to pause the video and try those problems before going on. Okay, so p would be the factors of 2, q would be the factors of 8. P over q. So the factors of 2 are plus or minus 1 and plus or minus 2. Factors of 8 are 1, 2, plus, that should be a plus or minus there, 4, and 8. And so we need to make every combination of those. So I'm going to have plus or minus 1, 1 over 2, 1 over 4, 1 over 8. Okay, and then 2 over 1, 2 over 2, 2 over 4, 2 over 8. So 2 over 1 is 2. 2 over 2 is 1, which we already have. 2 over 4 is 1/2, which we already have. And 2 over 8 is 1/4, which we already have. So this is the set of all the possible values of p over q. Number 2 is actually a little bit longer, and I've already used up some of the space, but I'm going to do my best to fit it in there. So in problem 2, I have p over q, factors of 6, 1, plus or minus 2, plus or minus 3, plus or minus 6, and then factors of 10, plus or minus 1, 2, plus or minus 5, plus or minus 10. So that's a pretty long one. We have a lot of combinations here. So I'm going to start with 1, 1 over 1, 1 over 2, 1 over 5, 1 over 10. Okay, 2. So I have 2 over 1, 2 over 2, 2 over 5, and 2 over 10. 2 over 1, 2 over 2 makes 1, so we already have that covered. 2/5. And then 2 over 10 is 1/5, which we already have covered. So now I'm going to go into the 3. 3 over 1, 3 over 2. 3 over 5 and 3 over 10. Those are all new numbers. And then 6. 6 over 1. 6 over 2 is 3, which we have. 6 over 5. And 6 over 10 is 3/5. Do we have 3/5? Yes, we have that right there. All right, so this is the list of all the possible values of P over Q, which seems like a lot to try, but without the rational roots theorem, you would just be shooting in the dark. So this is a good place to get started on trying to find your roots. All right, so now we have a more reasonable problem, number 3, because we actually have to find the roots here. So P over Q again. Factors of 2 over factors of 1, because my lead coefficient is 1. So this just gives me plus or minus 2 and plus or minus 1. So I'm going to try one of those numbers and see if I can find a 0 of this polynomial. So let's try -1. So I have 1, -4, 1, 2, multiply, add, multiply, add. It does not look like it's working out. So -1 is not a 0. Try +1. And I have 1, -4, 1, 2. Bring down the first one. 1 times 1 is 1, add, 1 times -3 is -3, add, 1 times -2 is -2. So this one does work out. 1 is a 0, so I'm going to write that statement. 1 is a 0. And if 1 is a 0, I also know that x minus 1 is a factor. Okay, so now I'm left with 1x squared minus 3x minus 2. And I would be looking for numbers that multiply to -2 and add to -3, but those numbers don't exist, so this is not factorable. Now I can still find roots, but they're not going to actually be rational roots, because the rational roots would be able to, you would be able to find those by factoring. But I'm going to find the roots using the quadratic formula, which I'll put over here on the side. X equals -b plus or minus square root b squared minus 4ac all over 2a. Okay, so x equals -b, that would be +3, plus or minus the square root. B squared, when I square -3, I get 9, minus 4 times a times c, c is -2, over 2a, so 2 times 1. Okay, so this is going to give me +8 because of the -4 times the -2, so I have 9 plus 8, which is 17. So I get x is equal to 3 plus or minus root 17 over 2. So 2 zeros that are not rational are 3 plus root 17 over 2 and 3 minus root 17 over 2. And then I also know that 1 is a 0. So if I want to find all the zeros, I could say x is equal to these two answers, comma, 1. Okay, so I'm going to stop the video here and I'm going to make a new video for page 2.